Okay, what I have here is I've got a VGL60 wiring system completely out of the kettle. The reason I'm doing this is to do like a training video on tracking down problems. Sometimes I get talking to techs on the phone, and they want to just replace parts instead of really understanding how the system works, and they wind up chasing their tails. So in this particular case, I'm just going to point out the components first on what we have here. I set up the burner. This is a single sense burner, meaning we have a gas pilot. It's got a single rod that acts as both the igniter and to sense a flame. And this particular model uses a spark plug wire. It runs all the way back to your box. And what happens when this box turns on, you get the spark, the pilot lights, the gas valve is told to come on from the box, it lights the pilot valve. Once that senses a flame, which usually happens within 1 or 2 seconds if you have a good flame, then what will happen is MV will get energized. That's your main valve from the box, and then your burners will start to light. The biggest problem we run into with these single rod systems is that they will not work sometimes. If you have a system that everything looks to be working okay, pilot comes on, turns right back off, that's usually because the box is not reading the proper sense microamps from the flame. What happens is this acts as a dual rod coming back to your box. It reads, the voltage is converted, and it reads DC voltage off the rod back to the box, and it's looking for a minimum. What we've started doing on these, because if you notice on the Vulcan and the same style kettle, there's a long bar that mounts the pilot, and these burners do not mount solid in the machine. They kind of float around on the jet and the bracket in the back. And what happens is you don't get a super ground. Your only ground really is through your pilot tube, and then your valve has a ground. So we found better to run a ground wire all the way back, and this one will be heat shielded when we're done. And then we run it to the steel plate where everything's bolted, and you've got another ground wire here that runs back to the gas valve. The gas valve itself has a ground wire that goes to your box. So everything is grounded. Your transformer is grounded to the plate, and then this metal that this is bolted to is also grounded to the rest of the machine. But what that does is give you a much more solid ground for the box to read. And just to go over components on this one, nothing turns on. You've got your main power cord that comes into a terminal block. It's 115 volt. It runs into your switch. One side of the switch will send power to the transformer. The other side will send it to your water light, which is an amber light. So what happens if you don't have power, the first thing you're going to meter across your fuse and make sure if your transformer is not coming on. If you have 115 to the machine, but you don't get 24 volts out of your transformer, then you're going to be looking at this fuse. The other thing is, when this first comes on, the first thing it does is test your water board. Right here, the yellow wire coming off the water board would normally go to water probe. I have it grounded here. Okay, this is only for testing. Some people will take shortcuts when this acts up, and they'll take this water probe and they'll ground it to the machine. The bad thing about doing that is now you're putting your machine at risk and yourselves, because you can have the pressures go crazy on this machine from overheating the bottom with no water in it. You can damage the welds. You just don't do that. If you got something that's not working, replace it. This is simply for testing, and we're eliminating this outside of the kettle. Same way you can test your water sensor, if it's dirty or not. Many times it's just very dirty, you got to clean it. But here in this case, you could ground your terminal. If everything's working fine but your water board won't trip off, you can ground your probe. That's working. Your water board comes on, and then replace your water probe. Now in this case, once that's satisfied, then what happens, your transformer powers up. Transformer powers up, and then we get the 24 volt side of this. This is actually a relatively simple system, because what happens when this energizes, we get 24 volts to here and immediately get spark. So if you're not getting spark, you're immediately going to check. You got 24 volts positive, and you got 24, you got a good ground. And your box, you'll see a little red light up on this box. A lot of boxes will have indicator lights telling you it's got power to the box. immediately what it's going to do is if there's a call for spark to the pilot, immediately once you get through the cycle, and it happens within seconds, this thing will ignite and you'll start hearing the spark at your pilot. Then once the pilot lights, like I said before, it's going to read the sense, and immediately you're going to get the MV to energize inside the box, and it will send 24 volts right through this red wire into our pressure switch. Now this pressure switch is a safety. It's kind of like a light switch. It's always on, meaning it always has continuity. These two wires are switches on. So the power will go through here, then it goes to your thermostat. If you have your thermostat turned all the way up and your thermostat is operating correctly, then it will get back and it'll start heading to the wire all the way to the valve. Quick way to test your two components, we put a jumper in between ours here. This is the wire going directly to MV on the gas valve. It's at the end of the trail. If you were to hook this right to here and take your MV off, we have bypassed the pressure switch and the thermostat. If our system fires up and works properly, then we're going to be looking at these two components. And sometimes these can act up, meaning they'll work, won't work. Put your meters on them. Jiggle the wires. Let it run a minute and see if you drop voltage out. But if you have voltage here and not here, then you're looking at your pressure switch. If you don't have it on this side of the pressure switch, check your connectors. Connectors are all good. Then you go to this. You can jiggle around with the up and down. This turns on at a low temperature. You can actually hear these thermostats click. Once they click from 100 on up, roughly to around 300 degrees, you will have continuity between this, and the bulb is what reads the temperature. It goes into your water jacket, and so let's say you turn it halfway down and it gets to 125 degrees, and this switch will cut out. If you have this all the way at hot and this cuts out at 100 degrees, 150 degrees and not 300, then most likely your thermostat. But again, check your power. If your power cuts out here, then you know this shut off here. You got power from this one, you know, okay, it's reading the thermostat. Thermostat cut off too soon. So then you go replace the thermostat. One major thing I want to show that we've come up with recently is the spark plug wires. We actually did it to ourselves. We bought spark plug wires from another source. Not thinking about it. These are solid core wires, single rod. The problem with the single rod system, it's very touchy of reading the sense. You don't have a second rod to read the flame. So that spark plug wire is also acting as your wire to read the flame sense when the flame comes on. A suppression wire, or what you see in your new cars today where it's almost like a fiber wire, does not read correctly. And what will happen, this thing will turn on, turn off, you'll chase your tail and realize it's a spark plug wire. So what we're doing is we're actually making our own now. We're making our solid steel core wires. And we had one the other day. It was packaged as a steel core wire. Without cutting into the wire, was no writing on the wire. We ran it here, it wouldn't run. Turns out that we cut the wire in half, it's a suppression wire. So really, if you're having a trouble with that and you've replaced the spark plug wire and it won't fire correctly, or it's been replaced, check that wire. And you can actually run a solid core wire just temporarily to there and make sure. But you have to have the high temperature spark plug wire in the end. But what I'm going to do now is just go through a couple simple tests. You hold the camera. Like I was saying, you put your meter on continuity. I do not have it plugged in. No power to the machine. You see here, I'm just checking the fuse. Same way I can check from one location to the next. Across here on the pressure switch. See how it's on all the time? That goes to here, over to here. So my wire is reading good. I go across the thermostat because the thermostat is on. It's reading. So now I've got continuity all the way to MV. So all I have to do is wait for power to come on this red wire, and this system will come on for the main burner. Like I said, you're checking everything in AC. Even the 24 volts when it drops goes to AC. So let me plug this real quick and I'll show you how to just do a couple quick voltage checks. Other thing to talk to you about safety too. When you're working on these things, I'm used to doing them. Be very careful when you're working with this. If you're not used to doing them either, then have an electrician come do it. Go put yourself through some videos. Make sure you have, I keep my gas tank real close so I can shut it off. And I only run this short term for testing. And don't run it. This is only a bench test to kind of just show people what you can check for on these and how basically this operates. In this particular case, you notice I flipped the switch on. You see the red light came on the water board, meaning it's satisfied. And if you listen, you'll hear the spark. Now right now I don't have gas on, and this is a continuous box. So this box will continue to spark, trying to light it. Okay? And if you notice here, I'm going to go into my common wire, which is the white, which ties into everything. And you'll see I have 20, if I can hold it in there. Get the ground. You see we have, that's basically our 24 volt side. I would turn the igniter off because the igniter is going to feed back. But when this came on, it basically powered up my box. I have 24 volts to the box. The pilot valve came on. You see right now I've got flame. Immediately here the spark shut off. Now that sparkle wire is acting as a flame sense, and it saw the flame right away from the pilot and immediately let me light the burner. So again, you can go backwards and check backwards. You can check on if you're not getting the spark out of your box, make sure your box powered up. Once you have spark out of your box, you want to make sure you have gas at your gas valve. So you check across your PV and your common, which is your MV/PV, and you should have 24 volts going to the valve, which ignites the pilot. Once that pilot lights, and within 1 or 2 seconds, it should turn on the main valve, and then you'll get flame out of the main burner. This is why I say, if this doesn't read the proper reading off this flame rod, it will not turn on MV. Let's turn this back off. Now watch what happens when I turn the gas off. Let's say that we just lost the flame. If the box is working correctly, it'll immediately go back into restart. But it can't restart because I didn't turn the gas valve on, so no pilot. But the box, if your box is working correctly, it'll go back into restart and start sparking again. And that's what it'll do when it cycles on the temperature. If you turn the temperature down, the pilot will stay lit, but the main burner will shut off. And as you turn that, because it only goes through the MV circuit, when you turn that temperature up on your thermostat, then what it'll do is your pilot will come on, and then it'll turn the MV on, and again it lights the burner all back up again. So this is the basic operation of this particular kettle, and you will find most kettles work the same way. I will show you one thing. Let me show you one thing I didn't talk about. I'm going to turn the system on normally. As soon as I turn it on, watch the amber light. That's your water level light. Comes on. Since we grounded the wire so it's satisfied, now turn stuff on here. And as soon as the main valve comes on, then we get the light for the main burner. So this is tied into the same line to MV. So as soon as it gets voltage to the gas valve, you should see a red light going on, providing your neutral wire is good. Now it's nice to do it this way. It's hard to show everything in the machine. What we're trying to get this guy to do is, that's working in Arizona, is to get the change, make sure he's got the good sparkle wire to start with. Go ahead and ground the system. Do your maintenance things out of the way. These did not come with these extra grounds. I'm seeing a lot of machines that have the single rod systems now going to extra grounds because as the machines get dirty and get old, and you can't get to these pilots that well, they're losing that rod, they're losing the microamps is dropping. And once it gets to a minimum, this box will go in and out. And you will chase your tail if you're looking for other components on it. But it's best if you walk through each system. Once you know these components are working, they're out of the system. Once your water level board's good and you're not losing power to your box, you've eliminated these parts. That's why the same thing you can do here. You can actually jump this over, and we'll do it in this case. I'm going to take the MV off the board. And if you notice, it's all tied to all this here. And it's tied to your pressure switch in here. I'm eliminating that. I'm going right to MV. So now when I turn this on, as soon as it sees that flame, it's going to come on and it'll stay on. So you don't do this either. This is only for testing. If you did this thing would run non-stop. It came on. Valve came on. See, I didn't have any thermostat or pressure switch hooked up. It went right to. So this is a great way to bypass these two components over here. Bypass the pressure gauge in this, and then you can go back and see what's going on there. So it's a great way to make sure if your system's working. Because what you want to do is find the problem with the individual part. Find out what's wrong before you replace anything. Once you start replacing parts, you put yourself in a non-winning battle. And if you watch any good technicians on YouTube, that's what they'll tell you. Find out how the system works. Follow the trouble tree exactly the way they tell you to follow it. Don't just start throwing parts at the machine. Just because a pilot fixed the machine the last time does not mean it'll fix the next one. And you might have just moved the bracket, or there might have been dirt in the pilot. The pilot or the ground might not even been the problem. So every machine's different. So if you understand how everything works, then you can go back and you can check each component, test each component, and make sure it's working the way it's supposed to. The other thing I would tell people too, what I see a lot of with gas components, a lot of technicians are so used to working to them, your good technicians today will put gauges on the gas valve. Just because your gas system's working fine in your building today does not mean it'll work fine tomorrow. Because as you add equipment, your gas pressures can change, your volume of gas can change, and that's why they put ports on the gas valve, so you can check and make sure your pressures and your volume is within manufacturer spec when this is running. And what I would suggest is run this machine, and if you've got 6 more, run all 6 at the same time and see if you see any drop. So your gas repair guy should have a manometer, which he can hook into these ports. In the future, they also should be running gas analyzers, because just like your automobile, the amount of carbon dioxide increases when this burn isn't as good. And even though it will burn fine, you could modify the jets a little bit and get a better flame. It's just kind of like looking in your grill. When it works the best, you see the nice pretty blue flame. But if you run a gas analyzer, it'll actually tell you if you're burning the most efficiently, just like your car. If you're not, you're risking getting exposed to carbon monoxide, actually causing yourself injury or death. All your buildings should have carbon monoxide testers in them if you run a restaurant or a facility using gas. So just a couple things I hope helps everybody with these. Going to try to start doing more of these where we break the systems down on the bench, and you can see how the different components work. They get a lot more complicated than this one. This is actually a fairly simple system that you do see, although the components will be bolted up differently in the machine. They basically work in the same way. So hope this helps. Definitely hope it helps the technician that's struggling with one of these. If got any suggestions or questions, please let me know. And have a great Thanksgiving.